Test, test, test.
Is the sound showing up on the stream?
Wait, it is. Hello, everyone. Welcome to HackJPS 2025. This is a hackathon hosted by J.P. Stevens High School students. Okay, so first of all, we'd like to give out a special thanks to our sponsors here today. So we have them displayed on the screen. They made today really possible, and we just like to thank everybody for coming out as well. A special thanks to our advisors and supporters, Mr. Giuliano, Mr. Kazi, Mr. Carney, the Edison Board of Education, and JPS administration, and everybody from our team that made today possible.
Okay, so most of you might be new here. So what exactly is a hackathon? So a hackathon is just a competition to code the best project in a limited number of time. So you don't have a whole week, you have a couple of days to make a project. And it's open to all skill levels, so we'll have workshops, even if you're a beginner, if you want to learn some new skills. There are also prizes given out to the best project. So I just mentioned the workshop. So what is a workshop? Workshops is just an interactive learning session where you can learn new skills that you can use in the hackathon. We'll have a workshop presented by NJIT and members of the robotics team. So here's our map of our venue. You can enter through the front gate, and we're in the cafeteria. So make sure you're connected to the HackJPS 2025 Wi-Fi. You can, if it's not working, you can ask the technical team or anybody who's wearing robotics merch. And here's our in-person schedule.
For the in-person schedule, we will be giving you time for idea formation. So from 9:50 to 10:25, you do have time to talk to your team. Teams are typically groups of 4 or less. At 10:30, we'll have our first workshop by Cyberhawks, and then 11, we'll have a workshop by Code for Hope. And then from 11:30 to 12, we'll have a workshop by NJIT Robotics. From 12:10 to 12:50, lunch will be served, and then so on forth will be a presentation by each sub-team at our school's robotics team.
So we have an overall theme for you to follow for HackJPS 2025. This is just to give you sort of a basic concept of what your project can be. So for our theme this year is creativity and art design. So often in a lot of these hackathon projects, UI UX design is often overlooked. And this is actually very important for usability and user interface for an actual project. And in industry, UI UX design is very important to make sure your app actually gets used by the users. So you can use design tools like our sponsor Figma to help you in this process. And how well thought out and artistically creative your UI design will be included in your scoring. So this year, specifically your creativity and artistic design of your project will be worth double the scoring points. So make sure you have a heavy emphasis on how well your project actually looks. It's very important that the user can actually use your project or application in the real world.
So now we'll be going over the various categories and prizes that we have for this hackathon. So the first category is Best Overall Hack. And all the projects that are submitted by students will be considered for this category. This is basically judged on a combination of technical talent, practicality, creativity, and your presentational skills for the short video you'll be creating. The prizes for this are for first place. There are Interview Cake, which is our sponsor. There's licenses for each member and a 2-year membership for each member of Codecrafter. The next category is Best Game Design. Game development is a pretty fun way to expand on your programming abilities. Projects submitted in this category don't necessarily need to be games written from the ground up. You can also modify or extend already existing games, provided your project adds some original functionality to this game. And for this, the prizes are Interview Cake licenses for every member again, and a 1-year Codecrafter membership for every member. And for second place, we have, again, Interview Cake licenses for every member, and 1-month Xmind membership for every member, and a 6-month Codecrafter membership, plus a Gen AI interview voucher. The next category is Best Youth Hack. So we understand that a lot of middle schoolers and younger students might be present here, and to make the playing field a little bit more fair, any team with more than half the members being middle school students will be eligible to receive this prize. And the prize is Interview Cake licenses for every member for first place and Amazon gift cards. Next category is the best use of AI and ML. If you indicate that your project uses any kind of artificial intelligence or machine learning, it'll be considered for this category. And the focus is on integrating AI into a project in a way that makes sense and is genuinely useful. So there's Interview Cake licenses for each member, a $10 Amazon gift card, and NordVPN security for all members. And for second place, again, Interview Cake licenses and Gen AI interview vouchers. The next category is relating to our sponsor, VerbWire. This is similar to the best use of AI, but this is for teams that use AI in conjunction with the VerbWire API. And you can use magicpilot.ai by VerbWire to build Web3 programs using AI. And up to 5 teams can win this category. All members of each winning team receive $45 of VerbWire API credit. And the next category is another VerbWire category. This is the most innovative use of the VerbWire API. And all members of each winning team will receive $45 of VerbWire Premium API credit. And the last category is for public choice. So this is a category where members will vote for their favorite project, and this project will be eligible for prizes. So the prizes are $25 Art of Problem Solving coupons and Interview Cake licenses and 3-month Xmind memberships.
So first of all, we'd like to thank everyone for coming out to JP Stevens to attend our in-person day for the hackathon. So all in-person participants at the conclusion of the hackathon will receive some participation prizes from our sponsor Figma. And to all our participants that decided to participate in our hackathon, we'll be emailing HackJPS exclusive promotional codes provided by our sponsors Balsamiq and FlatLogic, which has a total prize value of $5,400. Now for some general guidelines. All code must be written during the time frame of the event. Any attempts to exploit the network infrastructure will result in immediate dismissal and disqualification. Copying another team's project or submitting an external application without original modifications will result in disqualification. This is a team event, so 4 people can do more work in 36 hours than 1 person can, so feel free to reach out to anyone you meet here and whatnot. And so this leads us to a final prize value of $21,000 and more.
So in terms of an AI policy, we understand that AI has evolved a lot over the past few years, and for modern programmers, using AI is an effective skill that needs to be learned. So generative AI is fully allowed, but with a couple guidelines that you need to follow. Any use of generative AI must be explicitly stated in the submission page, and you need to give credit to the specific models and tools that they use, and if possible, state how they were used in your project. And this will not count against the value of the project, we simply need the information. They also must be able to demonstrate a clear understanding of your own code, and especially in your video part of your submission, which the details of are listed on DevPost. And you should not use AI to generate any part of your video or write any part of your project submission page. It should simply only be used for your actual project. And for all other info about rules, you can check hackjps25.devpost.com. All right, good luck everyone. Have fun, and submissions will close in 36 hours at 7 p.m. tomorrow.
All right, hello. I'm, oh, this one? Okay. Let me uh, this doesn't work. Hello? Okay. Hi, I'm Isaac and I'm part of Cyberhawks, which is a computer science club with like 4 main sectors. So today I'll just be giving you an introduction into web and game dev and like some of the things we covered in our club. So basically, the main structure of a website is just made of 3 parts, which is HTML, CSS, and JavaScript. And if you want to think of it as like a real life example, HTML is basically the structure of your website. It provides like the backbone, like your skeleton. CSS provides like the actual looks on the website and allows you to like change the different elements, like your skin. And then for JavaScript, it's basically the functionality or like your nerves, as it allows for your website to actually do stuff and also allows you to interact with it. So basically, in summary for HTML, it needs to be a .html file. It needs to be in between HTML tags. And for the majority of the elements that you use in HTML, there's both the start and end tag. But we'll show you some of the tags later, and you can see that. And so here's just the absolute bare like minimum structure. You can see at the top and bottom how there's HTML tags, and that's where you would include all your HTML elements. And the code is separated into multiple parts. As you can see, there's a head and body, and this is basically where you put your main elements. And your head is where you'd include like any like connections to other like files, and then like maybe your title page name or like your website name. And the body is where you put the bulk of your elements, like your text, your paragraphs, your pictures, or your links. And as you can see here, there's your very basic heading. It's just a singular heading, which is just H1. And so here's just a quick list. You don't need to like remember basically anything because you can always search it up. But a quick rundown is that there's 1 paragraph tag, there's 6 heading tags, and with H1 being the biggest heading and then H6 being the smallest, so depending on the size you want to use, you can just select a certain tag. You can bold and italicize on the same line. So if you want like a paragraph that's in bold, you can just put a bold tag inside the paragraph. You can underline, highlight, and then here's like some of the tags that don't need an end tag. You have just the break line, which just creates a blank space between your elements. And you also have a horizontal line, and then you can see here that you don't actually need an end tag. It's just a singular beginning tag. And then here's some elements that are probably more interesting. You can include a link, you can have an image, you can have lists, and you can create comments. And just the thing about the links is that you need to like find an actually working link or else it won't. And then you can also change what the link actually says along with where it directs to. For the image, you need to make sure that the image is in the same file or in the same folder as your actual HTML file, so then it can actually find the file and then just display it. And if like it doesn't, you can see over there how it says, how it just says puppy with no image. That's what happens when it can't find the actual image. And then there's a difference between ordered and unordered lists. Ordered lists just have numbers, and then unordered lists don't. And if you ever forget any of these tags, you can always just search it up. So moving on to CSS, which is basically just changing the color of the elements and just the other properties. You have a lot of different properties here, but the notable ones are probably just color, font size, and then font family. And that basically just allows you to change how the text appears. So there's, I guess, 3 main ways to implement CSS into HTML. The first way is just creating a tag. And in this first way, you basically apply the properties of your CSS to every single element of that type. So in this case, all the paragraphs in your HTML file will get the red color. You can also create classes, and instead of applying to every single element, it only applies to each element that you actually give the class to. So let's say you have a class.fontChange. Whatever element you give this this class to, it'll then get or its font will then change to the fantasy font. And then we also have IDs. It's like a class, as it can be called for a singular element, but usually it's only supposed to be for one, and if you try applying it, it could cause some problems in the future. So here's just a bare example of CSS in action. You can just write the CSS in the same HTML file. All you need to do is just create two style tags, a beginning and end one, and that lets your program know that it's starting in CSS. So in the first example, there is just your average tag, which changes all of the H2 elements. Then we have a class and an ID with that's called rname and then r small or m small. And then below you can see the actual HTML elements and its application. So in the first one, I'll show you on the next slide of what it actually turns out to be. But the H2 one would be much larger than the other elements. And you can see on the next two paragraph elements that they both have the same class and they have different tags, and they'll both have the same basic elements of basically the same font and color, but they can have different text. And the third one is just an ID, which basically just is like a class but for one element. And so this is what it would look like. You can see that the first one is just really large, which is how the tag was defined. And then the next two paragraphs tags have different text but basically the same properties, which is what you'd use a class for. And then the last one is just an ID. And then one thing for just structuring is called flexbox, or just flexible box. And it's basically just a way to horizontally align your elements. So by default, CSS and HTML will put your elements vertically. So if you just have 5 paragraph tags, it would just be 5 paragraph tags up and down. But if you decide to use like a flexbox and then I guess make it into a container, then you can just put like multiple paragraph tags on a horizontal line, which is really useful for actually organizing and ordering your elements. Okay, so that's HTML and CSS. Now move on to JavaScript and then eventually just game development. So you can either connect JavaScript with a separate file, which is what we're doing on top, or you can just write it in the HTML file like you did with the CSS file with just using script tags. But I'd say most people prefer to just connect it to a separate file, as it just helps with organization. And you can connect multiple JavaScript tags to to multiple HTML files. So you probably all know this, but it's basically just your basic if and else statement. Like if something's true, then something else happens. And you can attach an infinite amount of else if statements onto it, or just one singular else statement that'll run depending on the condition. And for loops, it's basically the same syntax as Java, if you know that. You just have your initial counter variable, then your condition, and then just your increment. And you can also have while and do while loops, and there's also a similar format where they just run until their condition becomes false. So we have arrays, and there's like multiple ways to define both variables and arrays. You can define as a constant, you can use let, or you can use var. They do slightly different things. Constant just makes it so it can't be changed. Let and var basically do the same thing, but let is like the more modern version, and like var is basically the same, but it's like less used in my opinion. And then, so there's a bunch of built-in array functions that you can use. And yeah, so arrays are basically just used to store multiple different pieces of data. And you can either store objects, sprites, or just other variables inside them. So there's a way to, I guess, have user interactivity. It's called using forms. And you can create buttons, drop-down screens, checkboxes, and just other forms that you can actually click on. And you'd write this inside your actual JavaScript file, and then you can then use it with your HTML file. So how to actually do that is you'd write your actual function. Let's say, in this case, it's just called my function. Write whatever you want your code to do. and then you can just make it an on-click function by adding it to HTML. And what this basically does is once whatever element in HTML gets clicked, so you create your button in HTML, but then you create the functionality in JavaScript, and when you detect that your button gets clicked, then you can run the JavaScript function, and you can use the same function for multiple elements and on-clicks if you wanted to do that. So moving on to game development now, what we do as a club is we use P5JS, and what that is basically just a built-in library, or it's just a library for game development and animation. And if you'd want to actually use this in your code, you'd need to include a few libraries. And another thing that's like nice about JavaScript is that, and just languages in general, is that there's already a lot of built-in libraries that you can access. So if you wanted to, let's say, find a certain feature like doing like text-to-speech, then you could probably find a library online, attach it to your code, look at the syntax, and then add it to your code. So like the basic syntax with, I guess, P5JS, which is basically the same for JavaScript, is just your setup and draw function. Your setup function gets run once, and it's basically where you define your variables and just stuff that only needs to be run once. And then we have your draw function, which gets repeated, and by default, it's 60 frames per second. And this is where the bulk of your code would usually go, as you usually don't want something that's just purely stationary. So I think one of the main components of P5JS is its built-in sprites. And with these sprites, you can do many things, such as, I guess, just changing their properties in order to fit your needs. And you can also upload pictures. And just like your previous pictures in HTML, you actually need the pictures to be, or images to be inside the same folder as the HTML file so that I can actually access it. And the basic parameters are just the image. And if you decide not to include the image, it just gives you a square. You have the X coordinate, the Y coordinate, and then the width and height. And if you just decide to not include an image, it'll just create a square at those coordinates with those dimensions. And there's a lot of built-in properties such as scale and also other ones that allow you to further, I guess, adjust sprites. And I think the second main component of P5JS is just user input, as it's really useful to be able to actually like press a button on your keyboard and then have something happen. So there's like three main ways of doing this. We have kb.pressing, kb.presses, and then kb.released. And this basically just says like when the keyboard does this or like releases this key. And so they may look similar, but there is a slight difference between them. Dot pressing basically just checks whether the key is being held down. Dot presses just checks if it's pressed once. And dot released returns true whenever the key gets released, which is pretty intuitive. And in this example here, it's just, it will just change the position of the sprite if the keyboard, if the right arrow is pressed, which is basically the main functionality of your user input. It just allows you to change the positions, properties, and other things about the sprites. And then if you want to check what key was actually pressed, you can just use console.log key, and then it'll just show you that in the console. And so there's no like actual borders by default. So one way that you can actually implement borders is by just checking for the sprite's position. So so in this example here, it uses for if statements and also the properties of the sprite, which in this case is player, and it allows you to check the player's X and then Y position. And by default, dot width and dot height refer to the width and height of the canvas. So this allows you to easily change the dimensions of the sprite, and then also have this basically just readapt to the sprite's new properties. And what this basically does is once it detects that a sprite goes out of bounds or just touches the wall, it basically just moves the sprite in an equal and opposite direction and speed. And so it basically just makes it look like that your sprite just hits a wall and stops moving, when in reality it's just quickly moving back and forth, but to the to someone's eye, it just looks like a border and they can't pass it. And so by default, sprites have their own colliders, and you can see like in that image there how there is a green circle, and that would represent the collider of like a circle sprite. So there's like multiple different, I guess, properties of the colliders. They can be dynamic, static, kinematic, or just have no collider. When they're dynamic, it's the default one, and it basically can interact with anything, and it gets moved around by anything. Static sprites can still be changed by code, but they can't be moved by other sprites. And kinematic sprites just can't be moved by other sprites, but can still be moved by code. And if you'd want to actually see the hitbox of a sprite, you can just use sprite.debug or just whatever name your sprite has. And so there's ways to check collision between sprites, which is, I guess, another major aspect, as you'd probably want two sprites to be able to interact with each other and then for stuff to happen after that. So you can either use .overlaps, .collides, or .colliding, and just like the different KB or keyboard functions that do similar things, these are slightly similar but have different functionality. So .overlaps will only return true if the sprites touches, and it doesn't allow for the sprites to actually move. Collides just checks it once, so if they touch once, then it'll return true, but it won't like continuously check. And then that's what .colliding is for. It'll continuously return true if two sprites are touching. So one thing to note is that static sprites can't actually interact with each other, which is probably one of the major limitations of this, as if you wanted two static sprites, let's say like maybe a tree and then the ground, to actually touch, they can't really do that due to the way that P5.js works. And a sprite hitbox will exist even if you like turn it off, which is kind of obvious, but it's just a note. And then sometimes a sprite will just decide to spin due to the hitbox collision. And if you want to prevent this, you can just turn the sprite rotation to 0 continuously. So you could put that in your draw function, and then that would prevent your sprite from like spinning continuously, which is something that you'd probably not want. And as you can see here, in this example, we have a block moving into an invisible wall, and then the hitbox will exist even if the sprite isn't visible itself, and it's returning true and just saying that the player is moving right when it touches the actual invisible sprite. And this just shows how the .colliding method works, as it just returns true and then prints out this text whenever the two sprites are touching. And then, so another thing that you can do is you can use sprite sheets if you want to add animations. Of course, there's other ways to do this, such as like, I guess, manually having each image, but sprite sheets are more efficient and probably lead to more, I guess, dynamic and more realistic animations. So, and then basically, the more actual individual like movements of a sprite you have on a sprite sheet, the better the actual animation would be. And sprite sheets are basically just images, so they need to be loaded into the code. And then they can also be used to make sprite sheets and actual objects. And if you wanted to actually use sprite sheets in your code, you need to include this library, since this isn't defaultly included in like JavaScript or P5.js. And so if you wanted to actually implement this, here's just some sample code. So you'd first need to actually define your sprite sheet, and you're basically just creating a variable to store it inside. And then you then need to load it in. And just like your previous images for both HTML and just actually creating sprites, you need this sprite sheet to be in the same folder as your HTML file, because in that case, it'll then allow you to actually find the sprite sheet. And then in the next, I guess, function, we have the setup function. And what it's basically doing is it's creating the canvas and then creating the new sprite with the sprite sheet, which we later define. And then for the draw function, it just basically just runs the sprite sheet, and then it also changes the background. And so for the bulk main code, what it's basically doing is it's overloading the sprite class to make it accept the sheet as like a parameter, and also to accept the number of frames. and then it's just setting all the properties equal to like the properties of this sprite. So we have this dot sheet is equal to sheet, and what this does is just ensures that the sprite that you create has this sheet as its property sheet, and then it does that for x, y, h, and then for frame, that just represents the number of frames in the image. So if you'd want, or so depending on how many frames you have, so in this case you have 4 in one direction, then your frame number would just be 4, and in this case n would be 4. And then it then sets the width depending on the sprite sheet width, which is one of the properties that you just define, and then you can then access. So the main bulk of the code is basically just actually drawing the sprite sheet. So one thing that you can do with sprites is you can give it its own draw function that will run like when you just call like the sprite name dot draw in this case. And what it's basically doing is it's drawing this image, and this image is a built-in thing with JavaScript and P5.js. You're giving it the sheet image, you're giving it the x position that you want it at, the y coordinate, the width, the height, and then the floor. And what the floor is basically doing is it allows you to actually change the how the sprite looks like depending on like what frame it's on. And then you're increasing the frame number by 0.1. So what the floor and then like what the floor function basically does is if it's not like if it's like a decimal value, and then sets it to the lowest integer. So let's say it's 0.45 or something. If you use the floor function, it would just turn it to 0. And this allows you to like more easily manage the sprites, as let's say each frame is a number. So 0, 1, 2, 3. Then once it finally hits 1, it'll then go to the first frame. Once it hits 2, it'll go to the second frame, and then third, it'll go to the third frame, and it allows you to create an actual animation using a sprite sheet. And just the last thing you need to do in order for this to work is to actually check whether the frame is greater than like the number of frames. So if the current frame is greater than like the max number of frames that you inputted, in this case is 4, then it'll set back to 0. And this just ensures that the sprite animation will continue playing, because if you don't, then it'll reach a value, and in this case, let's say 5, where there's no more sprite sheets and it won't display anything. So once you hit the max number of sprite, or the max number of frames, you want to reset the frame so that I can run through the animation again. And yeah, so there's a lot of online resources where you can further learn this, and yeah.
at the same time. Just
Alright,
keep
got it.
this like in your hand like
So
this.
this is a recording and that's to the room.
Yes.
Alright, got
Like
it.
just like this. You can keep it here.
And make sure not to hold it too close to your mouth, otherwise
Yeah.
it'll blow out.
Alright, okay. Hi everyone. Welcome to the Code for Hope Entrepreneurship Workshop. My name is Arya and I'm the founder of Code for Hope. What?
Lapel mic here.
Okay. Alright. Today we're diving into how you can take your hackathon project and actually turn it into a real business venture. With me today are Rania, our executive event director, Myra, our executive marketing director, and Krish, our executive outreach director. Let's get started.
So,
Keep the lapel mic here and talk.
okay. So, what is entrepreneurship? Entrepreneurship is more than just building a business. It's about identifying problems, creating innovative solutions for your problems, and bringing people and resources together to make it happen. Entrepreneurs are change makers, whether in tech, health, education, or beyond.
So why? Oh wait, how do I do this? Why entrepreneurship matters. Entrepreneurship drives innovation, creates jobs, and helps solve real-world problems. When you develop something meaningful, like a hackathon project with real potential, you're already one step into the startup world. And on a personal level, it builds qualities like leadership, resilience, and creativity.
The first step is identifying problems worth solving. Look for inefficiencies in everyday life. Talk to people, use surveys, track trends, and observe what's missing in existing tools. If something frustrates you or someone else, it might be a potential business opportunity.
Once you've identified your problem, use techniques like mind mapping or Scamper to brainstorm. Collaborate with others to gain diverse insights, and then organize your ideas by ranking them based on feasibility, potential impact, and available resources. Okay, so to begin with, our brainstorming techniques are mind mapping and the Scamper method, which basically just uses ideas like substituting your ideas with the different ones to get to know which one's the most best for your target audience, combining your ideas to make sure it's the most elaborate and the most efficient to start going forward with your idea, adapting in case of any obstacles or any challenges that come through along your way, and modifying to just make tiny different changes in order to get your final product.
So business model basics. A great product needs a strong business model. Define your customer segments or who needs your product. Then outline your value proposition, delivery channels, revenue sources, and costs. Tools like the business model canvas can help visualize this.
Your value proposition answers the question, why should someone care? Focus on your benefits over your features. Make sure you clearly say what your problem is that you solve and how you're better than all the alternatives. And back it up with real proof, data, testimonials, or early results.
Before launching big, build an MVP, a minimum viable product. Test it with real users, gather feedback, and iterate fast. This helps you validate market demand without wasting your time or your resources.
Okay, so what makes a compelling pitch a compelling pitch? So a compelling pitch tells a story. Start with a problem that's relatable to your target audience. Explain your solution simply, and then back it up with a clear business model, show market potential, and always be confident in your value.
Hook your audience early. Use simple, powerful language and visuals. Rehearse until you sound confident and support your claims. Investors want to see that you've done your research.
All right, from hackathon to startup. Many startups began as hackathon projects, but what makes the difference? Having a passionate team, a clear roadmap, and constantly refining your prototype. Every project won't become a business, but every business starts with a project.
Okay, so securing resources is one of the most important parts about starting a business from a hackathon project. So to take things further, look for funding from competitions, investors, or incubators like Y Combinator. Network mentors, build partnerships, and every resource you add can help you scale faster.
Good marketing is everything. Define your story. What problem are you solving? Who's your customer? Build a brand that resonates. Use social media, feedback, and even small pilot groups to amplify and refine your message. So if you would look at our slide projected up here, we have some effective methods in order to market your project, including clearly defining your problem, validating its market fit, and etc.
Common challenges. You will face challenges, conflicts, failures, financial limitations, and that's completely normal. Communicate with your team efficiently, stay adaptable, and most importantly, don't give up. Learning from failure is all a part of the journey.
All right, key takeaways. Entrepreneurship is about solving real problems through innovation. Build strong models, deliver clear value, and pitch with purpose. Be creative, resilient, and always keep learning.
So what can you do now? Reflect on a problem you care about. Learn the tools we shared today, like Scamper and the others. And take the first step, prototype, test, pitch. Your idea could be the next big thing. If you have questions or want feedback, let's chat. So now we're gonna do a short question segment. If you guys have any questions. Do you guys have any questions for us? Questions, comments, anything? None? All right, thank you guys for listening.
How about we discuss their entrepreneurial ideas?
If you want to discuss your hackathon ideas with us, we're gonna be here.
Oh, we will be free to give you any insight.
Like we'll walk around and then talk to you guys. All right.
For your entrepreneurial ideas.
Thank you.
Okay, thank you. Almost clapped for myself.
Test, test. Good. All right. Hello, everyone. My name is Krishan. I am from NJIT Robotics. I am the external relations manager there. And I'm also going to be a sophomore in electrical engineering with a minor in drones and robotics. So if anybody has any questions about that after this presentation, come talk to me. I'm also a JPS alumni from the robotics team. I graduated last year. So today I'm going to talk to you about how to incorporate the engineering design process in, your hackathon project. I know this is a beginner-friendly hackathon, so some people might not know where to start. So if you don't, I'm here to help you with that. But before I do that, I just want to tell you a little bit of the NJIT Robotics Club itself. We're roughly at least 100 members, comprised of mechanical, electrical, computer engineers, along with some computer science and some business majors. We have a variety of projects such as the Swarm project, which is basically all these microbots that go on a whiteboard and they draw for you. We also have a newly made combat robotics league at NJIT where you can make tiny robots, big robots, and compete with them. We also recently made a first robotics competition, Robot in 3 Days challenge this year. So myself and a few other FRC alumni decided, hey, it'd be fun if we have a 3-month-long challenge for high school compressed into just 3 days for college students so we can, make a basis of what these high schoolers make their ideas off of. So these are just some of our projects that we offer, but we also give money to people who make their own projects. We give them a stipend and they can create whatever they want as long as it's a viable product. We also do some volunteering. So we volunteer at schools around Newark, mainly in robotics and math tutoring. We also do FRC tutoring, mainly for Science Park High School Team 752. We work with them closely. We also are heavily involved in VEX. We host 2 VEX competitions a year, one in fall 2025 and one in spring 2026. And we host roughly 300 elementary to high school teams. So are any of you involved in a VEX team? Okay, so most of you, if you're from this region, go to our events, whether it be the signature event or the New Jersey State tournament that we host. And since January 2025 alone, we accumulated over 1,360 hours of volunteer work. And finally, we have, oh my God, I'm so sorry, projects and volunteering. And we also have our competitive robotics league, which is a part of the VEX competition for college students. We get basically given a new game every year that we have to work with, and we compete against other universities in a time trial tournament, a bracket-style tournament, and a engineering design process documentation tournament per se. It's just you document everything you do from the beginning all the way of May of 2025 to May of 2026. You basically write everything you've done in the engineering design process. And personally for us, we roughly get 5 awards per year, and we have gone to Dallas, Texas for the past 5 or 6 years, 100% World's Rate. So enough about the actual club itself. We're going to talk about the engineering design process. Does anybody know what that is? Cool. So it's basically a methodical approach to problem solving. There are so many ways you can solve a problem. The engineering design process is more of a streamlined method that gives you stages to think about each part and how you should approach it. So there is no one way to approach a problem. Everyone has their own method, but I'm going to talk about the engineering design process offered from VEX itself, what they promote. And why do we want to know this? It encourages creativity while staying focused on practical goals. You have 24 hours at a hackathon project. You need to make sure you don't, think for too long. You got to work on a product somehow. And it also helps teams communicate clearly through defined stages. So now we're going to go into the steps of the engineering design process. You first identify. You identify your problem, and then you brainstorm possible solutions about that problem. You then want to select a certain solution, build that solution, test that solution, and you can repeat this process for either you're identifying the problem or brainstorming various solutions. So initially, for identifying the problem, your goal is to first define the problem clearly. So you can have an overall problem, or you can have a specific problem, and you got to figure out what you want to exactly solve first. For example, at a hackathon, you got to figure out what is that hackathon topic, or are there any subcategories I want to try going for? Like I saw the best UI from Figma. What if somebody wants to go for that? You can go for that. Make that your problem, your goal. Then you want to research background, constraints, and goals. So what have been tried before? What are some boundaries, and what are some goals you want? So for example, some backgrounds you want to consider are your team's experience. Who knows C++, who knows Java? Tell me what you're good at. Are you good at using APIs, etc. The issue is you only have 24 hours, and your goal is to make a minimum viable product by the end of the 24 hours in order to present it and possibly win. And you also need to understand the needs of the user. So in this case, for a hackathon, it would just be the judges and hackathon participants. But if you look at it from a larger scale, you could have somebody, doctors, teachers, etc. You got to choose your market. Now you got to brainstorm your solutions. So you first need to generate a wide range of possible solutions, and you got to think about it. What are all the ways that I could tackle the problem given to me at this hackathon? You should always document all your ideas. Write down everything you're thinking of. For example, I can make a calculator app. All right, how should I approach this? I could make a website, which is a calculator, or I could code in a different language and make it a executable file. You can also, I highly suggest you encourage creativity without judgment. So that basically is let everyone speak. Not every idea is a bad idea. It's just a different approach. So you make sure that everyone in your team has a voice and don't hold off from ideas too early. One of my favorite examples are phone number UIs. So everyone knows the classic, you enter your phone number in, or you just type in your phone number, right? That's one way to approach the problem of writing your phone number in. But people have also made stuff like a randomized phone number generator, where you got to keep pressing next until it's your phone number. You also have something like there's a slider, and you got to finally pick your phone number. So these are all tedious tasks, but my favorite one is the Etch-a-Sketch phone number, where you have to draw each digit on a phone on the Etch-a-Sketch, and you just hope that the computer recognizes it. And they're all valid ideas in theory. They all solve the solution. It's just how you approach it. What you need to analyze is if it's good or bad in each scenario. And how do you do this? You basically need to finally select your solution after you've brainstormed a whole list of ideas you want for this project. For example, you should evaluate the ideas based on the feasibility and impact. Can you realistically build this in the time frame and what we have, and will it solve the problem? You should also compare the trade-offs or different alternatives to a method you want to do. Like maybe I can write this in Java instead of C++, something like that. What are you gaining or what are you giving up when you put this in your project? And you should finally choose the best solution based on a design matrix. I'll get into that in a bit. So for a hackathon, I suggest you make a needs, want, wishes for your project in like the first at least 3 hours. Choose what you want to try, what's your goal, what you want to hopefully work on, and if you have time remaining, how can I make this cooler? So you should also create a list of pros and cons for each idea you make, and you should ask yourself questions like, can I realistically integrate this with this and finish it in time? Is it going to be too hard for me? Is it going to be, or do I want to challenge myself and do I want to learn? Also, something like a live analytical dashboard might be really cool, but also might be time consuming to make, when instead you can make a quiz app in that same time that might be better catered to the user experience. So these are all things you should consider, all through the design matrix. So the design matrix is your 2D matrix where you're able to compare ideas to personal criteria. We use this all the time in Vex Robotics. This is how we choose what part to put on a robot, etc. So we scale each idea from a 0 to 5 on how the least viable to most viable in that criteria that we're given. And we basically say the highest score is the objective choice. That's what we'll go with first. So for example, a hackathon, you might have your criteria might be, is this useful? Do I use AI in this? Can I finish this in time? Or does it follow the criteria for this award? You basically score it up, and in this case, you can see idea 4 has 16 points. So we work with that idea. So for example, which front end should we use? Do you want to use React? Do you want to use basic HTML, CSS, JavaScript? Or do you want to use something like Vue? These are all different approaches to the problem. It's your choice to choose how you want to work on it. Now you actually need to build your project. So you first need to develop a prototype or working model, and you got to figure out how I can do this quickly and cheaply. So for you guys, the simplest way is to do it with Visual Studio Code and GitHub. These are free softwares. I feel like everyone should have it on their computers, hopefully. You should also use tools and materials that at your disposal, and if you have the opportunity, try to take it in. For example, VerbWire or Google Cloud. Google Cloud has free credits for students if you are interested. And you could use Figma or you could use Rapid AI. You should also document everything you do with your design changes because you might understand it, but somebody else might not understand it. And it's important to constantly update your push commits on GitHub in case you need to revert or if you need to figure out what you're working on. It's really important to keep documentation for mainly like at the end of your hackathon project before you're about to submit. You're always asked, what is this project for? Why did I do it? So if you include your documentation, you can also show what we wanted to do, our timeline, etc. And then you have to test your actual product. And you first do this by assessing performance against your initial problem and goals. Is it doing what you hoped you wanted it to do? You also should do some testing with your product itself by collecting data and observing the outcomes of it. What does the evidence say rather than what you think about your product? You should also identify some strengths and areas for improvement in your project itself. What worked well when you tested it out? What do you think could be improved about it? And after you finish your, for a hackathon specifically, for any coding in general, every time you finish setting up your basic functions or key things of code, you should always test your code thoroughly. You should manually reread all your code for any logic errors that you might not have recognized. Don't just rely on IntelliJ to show you everything. You should also try various cases, edge cases, etc., to make sure you don't get any false positives. It's really important. Like, you don't want a judge or somebody testing your hackathon project and they don't get an output that you expected them to get. And now you repeat this project. So you want to refine the design based on your test results, figure out what you need to tweak or rework if you need to change the size of something on your website per se. You should modify and retest as needed. And you got to figure out how does your one change affect your whole project, because the smallest change could just break everything, frankly. If you, for example, put a public class in a private class by accident, you basically screw up your code. And you want to continue until all your requirements are met from that needs, wants, wishes list. And if you're satisfied, then you're done. So personally, I don't have anything for a hackathon. It's just you always test your project, continue adding on to the different ideas you have. But from a robotics standpoint, what we had to do is we make 6 robots a year, 2 pre-season, 2 during the season, and 2 before we go to Worlds. So in order to do this, we constantly CAD our robots. And if you look up here, we have on the left side, we have version 1, and on the left side, we have version 2 that was going for Worlds. So we had to change our design of the robot by doing the engineering design process all over again because we noticed the meta changed. So we did that, and we first tested it again. We modified it again to have bigger wheels at the top of the conveyor, and we noticed change in our output, and we had a more consistent output for our scoring mechanism for this year's game, which was to score rings on a goal. And finally, we were able to get our final product. And now, this is a basic overview of what I've said so far. There's 6 parts: identify, brainstorm, select, build, test, and repeat. So identify is basically understand your problem and define what needs to be solved. Research all the constraints, goals, requirements, etc. Brainstorm. Generate as many ideas as possible without judging them, and explore creative and unconventional solutions. You should then select ideas based on criteria like feasibility and impact, along with choosing the best possible solution with clear justification in what I recommend, the design matrix. And then you have to build the actual product, which you create a prototype of the model with a select solution, and use available tools at your disposal to work on it. Then you want to test your project by recording performance and comparing it to the original goals, identifying your failures, successes, and opportunities to improve. You finally want to test it and basically test again and again based on your feedback of yours and other people's feedback. And then finally, you should continue refining the solution until it's what you want. So that is all that I have. I might have bored some of you out, but does anybody have any questions? If anybody has any questions about robotics, VEX, anything STEM related or college related, I'll be here a little bit after if anybody wants to ask me questions. Thank you for your time.
up, right?
Yeah. All right. All right. This is a presentation for the programming sum team. So a little bit about us. The 25 to 26 captains are me, Rohan Saxena, Daria Sarvea, and he's not here right now, but Abhinav Sentikumar. And a little bit about what we do on the actual team. We help program the robot. So this would be all of the different subsystems, which are intake, drive, elevator, pretty much any part of the robot that needs to be moved, we program that. And for our slides today, we're going to be doing an introduction to machine learning. So our first topic is teachable machine. It's essentially a web-based tool that was made by Google. You can use it to classify images, audio, poses, or any other type of data, and you can do all of this without writing code. Essentially, you feed it information, and it trains the model. The model is TensorFlow, TensorFlow.js. It's essentially a library, a machine learning library. It can be used in several different languages, including Python and, in this case, JavaScript. And it gives you like the code as a background, so it does all of the heavy lifting for you. All you have to do is train the model and write the basic code based on the model you want. And some of the data you can give to it could be images, videos, anything else, any other type of data, including files. And now this is an example of a sample of what you could give it. So in this case, we have several different images of a thumbs up of a person, and you give it slightly different images for its database, so it has variety. And whenever you want it to detect an image that you're giving, it has multiple different images that it's trained on in multiple different scenarios. So whatever you feed it, whatever image you want, it can correctly identify what that image is showing. And for the next slide, let's create a model. So there are a couple different key terms in terms of machine learning. One is an epoch, which means one epoch just means every single training sample that you've given it. So whatever database of images that you've given it, it's been fed through the model you created through TensorFlow. Training samples, which is what I talked about before, which is essentially the image databases. That's what's actually used to train your machine learning model. And testing samples, this you don't give to the model. You use it to test how accurate your model is. So testing samples is what you give to train your model, training samples is what you give to train the model, and testing samples is what you use to test the accuracy of the model. And this is just a link you could go to for training. Okay. So now let's actually use the model. So there are 3 steps. One is to train your model with the training database with images, or so like an example could be you want to train it on recognizing numbers. So your database would be of several different numbers with different handwriting, different sizes. Next, you want to export and upload your model. And on the next slide, we have a code snippet that you can use in your preferred code editor. So if you were doing this, you would put this code into your preferred editor, and you could use this code to train your model. It's just HTML. And so this would be a sample of a machine learning model where when you click start, it starts training the model, and it'll tell you the size and the epochs and etc. And some of the main takeaways from this is the software that Google created is an intuitive way to start learning machine learning without having to know any code, any languages, without having to write any code. And it gives you an easy way of handling your database is handling your training database, your training model, your testing model, your training database, your testing database. And it just gives you a nice GUI to actually learn machine learning. You don't have to just look at straight up code.
So now, getting into now getting into LLMs, which are in essence large language models. First of all, an LLM is, you might have seen a lot of companies in recent times kind of launch these new types of chatbots, which can help you basically answer any question, like OpenAI, Gemini, DeepSeek, or Claude AI. And in essence, the way they work is that for now, they're just a black box called a transformer. And given a sentence, they are trained to predict the most probable word that will come next in the sentence. We don't need to get into the math behind this right now. All we need to know is that it will basically turn the sentence into a sequence of numbers, which it will process using machine learning, and it will predict the next word that comes out in the sequence. And if you look at the Google Colab link, here's the code that kind of runs a sample of an LLM. In essence, what it does is that we use the Hugging Face Transformers library in Python, as we see up top in those slides. And in essence, what it does is that it takes a model and asks it what is binary. In essence, what it is doing is it is tokenizing the sentence into small pieces, also called encoding the sentence. And it is giving it to the model to generate the next couple of next couple of words that complete the response. And then after that, we just decode the output, and that gives you the response that ChatGPT has. In essence, if you want, you can run this at home if you want, but an important consideration is that these large language models are extremely large in size. In particular, ChatGPT uses about 400 gigs of RAM on the server side per instance. So therefore, if you want to run this locally on your computer, just consider the amount of RAM that your system has and keep that in mind while running them. We will now be taking any questions. Okay, thank you.
unmuted. Now your voice is going to the stream, and you have to talk into this one.
Okay. Into which mic?
Hold the laptop mic like here.
Okay. I don't know. Hold it, bro. What's up, guys? We're going to be starting the HackJPS mechanical workshop. I'm Midansh.
You didn't even turn the mic on.
You're on the bottom. Pull it up. No.
This, bro, this. This is switch. Alright, what's up, guys? We're going to be doing the mechanical workshop now. I'm Midansh.
Explain the mechanism.
I'm Sridhar, and I'm Shasta. So the mechanical team is sort of. So the mechanical sub-team, what we majorly do is build the actual functional part of the robot itself. We work with different metals, woods, everything to create the actual robot itself, the physical build.
We also design the robot depending on the game, and we're gonna talk about one of the games that we did this year in the upcoming slideshow.
Okay, so this is the game.
So we'll start off with the game. So this year's game was called Reefscape, and the primary task of Reefscape was to drop coral onto this thing called a reef. And as you guys can see from the picture up there, the reef are these purple bars that have like. Okay, you can play the. We're gonna play the video.
Yeah. So game animations.
Welcome to the 2025 First Robotics Competition game, Reefscape, presented by Haas. Two alliances of 3 teams each compete to earn points by harvesting algae, seeding coral on their reef, and returning to their barge to ascend to the ocean's surface. Alliances earn additional rewards for meeting specific scoring thresholds and for cooperating with their opponents. Prior to the start of the match, teams can choose to hang a shallow cage or a deep cage on their barge. Robots start each match at their starting line and may be preloaded with 1 coral. During the first 15 seconds of the match, robots are autonomous and can be programmed to leave the starting line, remove algae from their reef, and play.
Okay, next we're going to show the designs for some robots. Okay, so these are some winning teams this year and designs that really worked out throughout the season this year, throughout Reefscape. And we have Miss Daisy, which was a team that won the Lehigh Championship. So if you want to watch the video real quick. Forget it. You want to talk about designs?
So now we're gonna talk about the engineering design process. Okay, so these are 2 other teams that played really well this year at our competitions. And these teams, we're just mentioning the teams that went to our district, which is First Mid-Atlantic. And we have Miss Daisy, Petty Robotics, and Midnight Inventors. So if you look at all these robots, they're pretty great robots. Miss Daisy's a really complex robot, but some of these robots, including the winning ones, do not have to be very advanced. They can be pretty simple and still win.
Yeah, so just one thing about Miss Daisy is that there's different design concepts. Miss Daisy had a ground intake, which these all consider into the strategy of the game. There's different things you could do, like pick up the coral from the ground rather than going to the human player station every time. So you really have to design your robot based on the strategy you want for that game. Hence, Miss Daisy had a different strategy and a different design overall.
All right, so now we're going to go into the engineering design process. So, okay, you guys have probably seen this before, and this is often the process of how you come up with designs and for like our robots, and initially like actually make a proper design to help us build this robot. And with FRC having existed for so many years, there exists like many similarities between previous year challenges and new ones, and that's where we can all look for inspiration between the engineering design. And to start off, you have to ask yourself to identify the task of the game, and then to research how you can make a good design, something that will really provide a good outcome. And you got to imagine, you got to plan, and then finally you create. And when you create these designs, you want to show that yourself that, you know what, I can get a good outcome. And then eventually you test, you improve, and then you keep on doing better and better as time goes on.
So this is a picture of our robot that we built this year. As you can see, there's just four major components we had, like the elevator, the intake, end effector, and overall making sure that our robot was durable because during competitions you're gonna have other robots slamming into your robot. You're gonna be rammed into the walls, things like that. So you have to make sure you have a durable robot, and that all these three major parts, the elevator, intake, and end effector, can survive all of those crashes, right? So as you can see, we have a picture. The piece with the PVC pipe, that is our end effector. So it's mounted on an elevator that climbs up and down to reach and score on the different levels of the reef, because there was the L1, L2, L3, L4. Aside from that, we had our intake, which was a slanted polycarbonate and plastic plate, which helps slide the PVC coral down into our end effector and eventually score those.
So these are some important considerations you have to make when building a robot. So one of these considerations is the type of drivetrain that you're going to use. So a lot of the really good teams, they end up using a swerve drivetrain, which essentially each of the wheels are able to rotate around and move, so that each of the wheels uses two motors. And this is best because compared to mechanism wheels, which allow both the drivetrain to move completely sideways, swerve wheels have a lot more traction, which is pretty necessary, especially if you don't want to get pushed around in the game. And then there's also a tank drivetrain, which isn't used as much, but it is still a viable option, and we do see teams using it in competitions. Next, we have size. There are limits to the size. You can't have an abnormally big robot, but depending on the size of your robot, that will impact your play style and actually what you're going to be able to do. Bigger robots are naturally better suited for defense, which is an important aspect of the game. And then we have weight, which is also important for defense. With the weight, if you have a lot of weight on your robot, you're going to be able to sustain a lot of hits, and also a lot of games have a climbing aspect. So having a lighter robot will allow you to climb faster and more easier.
Okay, so coming into complexity, like we said, designing your robot is a really big process, and that really helps you and your team understand how good you can do, how to optimize your output to make a better decision, right? And something you really want to keep in mind when designing and making these robots is the KISS standard, which means keep it simple, silly. And this basically says that, just because your robot is simple does not mean that it won't work. Having a overly complex design, a overly complex robot might just in general have in turn break it down or something like that. Okay. So if you guys want to try out, what I want you guys to do is just grab a piece of paper and design certain parts of a robot of maybe games from past or maybe the game this year, and let us know how you do. Thank you.
the driver commands. Then it sends the signal to the robot. There's multiple I/O options: USB, CAN, PWM, DIO, analog, SPI, I2C.
Next, we have the Power Distribution Hub, the PDH. The PDH replaces the former PDP, and it basically controls and directs the flow of power to other electrical components from the main battery. You can think of it as a fuse box in your house, like it takes the main power from the battery and distributes it to the other components of the robot. The PDH has 20 high current, 3 low current, and 1 switchable channel, and it also displays the battery voltage. The CAN chain usually ends at the PDH as well.
Next, we have the VRM, the voltage regulator module. It provides stable voltage outputs to components that can't run directly off the PDH by stepping up or stepping down the voltage. The outputs are regulated 5 volt and 12 volt power. It's used for sensitive parts like the radio, Ethernet switch, cameras, and small sensors.
Next, we have the radio, the open mesh radio. The radio is basically the wireless bridge between the robot and the driver station. It allows us to communicate with the robot from a distance, and it sends and receives signals so we can control the robot from far away. It's wired to the VRM because it can't handle fluctuating voltages, and it's connected to the RoboRio Ethernet port. It should be mounted in a spot with good signal strength and minimal interference so as to not lose communication with the driver station easily.
CAN stands for Computer Area Network. It's basically a two-wire network designed to facilitate communication between different parts of the robot. So that includes the motors and other systems. There's daisy chaining, which we use to connect the motors to basically help us with wire management. There's a CAN bus bar that helps us, and each device has a unique ID and shares the same bus. It's faster and it's more efficient than PWM, very helpful for finding mistakes during competitions and stuff.
Next, we have the motor controllers. So it takes the signals from the RoboRio and it controls the motors. It can regulate speed, direction, and the brake. It can also read sensor data like encoder position. So some examples of motor controllers are Talon FX, SparkMax, Victor SPX, used during the first competition. Can be controlled via CAN or PWM, or it can be powered through the PDH.
Next, we have the actual motors. So the motors basically transfer electrical energy and change it into mechanical energy and basically make the robot move. They're used to drive wheels, arms, elevator intake, shooters, etc. And they're controlled by the motor controllers we talked about earlier. There's 2 types of motors, brushless and brushed. The brushed motors, like the name says, has brushes in them, which used to move the motors, but the brushless motors have electronic components which makes the motors move. The brushless motors are much more efficient. Some of the motors we use for FRC are Neo and Falcon 500, but we mainly use the Neos. Moving on to sensors.
So one of the sensors we use is the camera. It basically provides vision to the drivers and enables autonomous targeting. There are USB cameras, there are several different types of cameras. The main one we use during the competition is the Limelight. It's basically a smart vision camera made specifically for FRC. It's real-time, it has real-time imaging processing. It tracks with retroreflective tape, APRO tags, or custom targets, and it basically provides a lot of data like TX and TY. And it connects to Ethernet port on the robot radio.
Next, we have the gyroscope, which can measure the angular rotation. It can also track the orientation. It helps with autonomous driving, turning accurately, and maintaining orientation during the gameplay. You can use NavX, Pigeon IMU, and you can combine it with the encoder for more accuracy.
Next, we have limit switches. Limit switches are basically used to detect end positions of moving parts and act as a trigger when the mechanism reaches the physical limit. So basically how they work is it moves in one direction. When the physical trigger is triggered, it changes direction, moves to the next. It plugs into
plugs into DIO ports on the RoboRio. And some motor controllers have limit switches input directly in order to stop damage from the motors going too much in one direction, some don't. And if triggered, robot first stops the motor, resets the encoder position, and prevents movement in one direction.
So magnet encoders, they basically measure the position or rotation of a shaft or motor. They connect directly to the motor controllers or the RoboRio for direct reading. Absolute motor controllers, they basically report the exact position of a shaft at all times, and they're useful for arms, turrets, rotating joints, while relative motors, on the other hand, they basically measure change in position. They need to be zeroed at, and they're useful for drivetrains, shooters, and elevators.
And finally, this one is a really underrated system, but wire management is very important, especially for electrical teams or people working with electrical components. It prevents disconnections, short circuits, and match failures. It keeps the robot organized, safe, and easy to troubleshoot. It adds slack. You can also add slack near moving joints to make sure the wires don't get disconnected, tear apart, get damaged, or other parts get damaged. Makes sure everything is color coded. This one is really underrated. Usually it's easy to take any wires, but it makes it easier for the whole team to understand what they're connecting to. Labeling is also very important. Zip ties are one thing to keep the wires in check. You can also use Velcros to take the wires out if you want.
That's it for the electrical.
Thank you.